Okay, tonight we're going to talk a little bit about network media and how it works with layer 2 and down. We're going to talk a little bit about how to plan out a network with VLSM and things of that nature. And then, since you've got the preliminaries and understanding of the basic network infrastructure, we're going to start getting into the command line interface tonight. And I'll explain how things go. And there's some nice charts in here kind of explaining what levels you're on and things like that. Okay? Identify several characteristics of Ethernet in its early years. Okay? Remember, in the early years, we just had the bus network, and then we went to the star network where you have that hub in the center or switch in the center, right? Well, what it came to is we migrated to an Ethernet switch instead of a regular hub. What that allows to do is to switch between all these different devices in multiple types of devices instead of one device. What's cool about point-to-point is from this building to this building, I have a point-to-point connection. Each one of these will be a point-to-point, and then you have the minis out here. Okay? Point-to-point, remember, are going to be your WAN connections. Like I said, we're only talking about the 802.3 Ethernet, 802.2 Ethernet. Notice how we split the data link in half. We have the MAC address. We have the MAC address, or the MAC, media access control method of the data link, and then logical link control of the data link. And that separates between the 802.2 and the 802.3. Make sense now? Now that you can actually see what we talked a little bit about last week. Layer 1 limitations. It can't communicate with anything above it. Can't identify devices. Can't do anything. Layer 2 connects those single devices upwards. Okay? It's kind of like your hardware abstraction layer. Does that make sense? If you're talking in Windows terms. It can't identify the devices. Well, it uses IP addressing at layer 2. That's why you come into packets. Only recognizes streams of bits. Well, it takes the bits and puts them into frames and then into packets and then into segments. Can't determine the source of a transmission when multiple devices are transmitting. Well, that's where layer 2 comes in, because layer 2 devices start reading MAC addresses, right? Remember, at the frames, we started looking at the MAC addresses. The media access control. It says it performs your error detection, your addressing, and delimits your frame. That's all it does in that data encapsulation. Remember, we have the headers and footers of the frame. That's what it does. Media access control, all it does is say, here's the media. All right. All these are basic Ethernet stuff. You have your UTP patch panels. You have switches, fiber, and Ethernet switch, right? Those are all physical. So, when we talked about CSMA CD versus CSMA CA, right? The avoidance versus the detection. In this instance, we're talking about the detection. So when B sends a package, it looks to see, is there anything that I can collide with? Yes, I can collide with D. I'm not going to send it. I adjust my time before I resend. Does that make sense? And we're talking milliseconds, so nanoseconds. Okay, collision detection. It listens before it sends anything. And if it hears that something else is out there, then it doesn't send anything. That's what carrier sense means. Okay? Multiple access means you have multiple things connecting to that backbone. Here's the difference between an Ethernet frame and an 802.3 frame. You have 7, and then you have a start of the frame delimiter versus the preamble. Both have destination sorts. Then you have the length and type, where you have the 2 here. Your data is going to be the same, except you have a header in the 802.3 standard. And then you have your frame check sequence, which basically just says, here's how big my field is going to be. All right? So what does a MAC address do? All it does is if we have a lot of shared media out here, it knows that that frame is for that specific person by that MAC address, just like an IP address. But when you're talking frames, it doesn't have an IP address because it's not being routed. MAC address is more of a broadcast type based address. Oh, wonderful. This looks very familiar of what you might need in Riddle 3. Didn't this also look very familiar right here? Riddle 1? Knock, knock, knock. Cameron, you're keeping your mouth shut?
I disagree.
Why do you disagree?
I quit. I gave up.
Because you haven't got to the slide yet?
I haven't.
It's this right here. What did I say? B or 1011? What do they both revert to in decimal? 11!
I went to your office, which had 11. You don't want 11?
Wasn't that?
Did it go?
Okay. So now we're talking about a unicast, multicast, broadcast. Now we're talking about the Ethernet frame versus an IP. The IP packet has the user data, it has the source and the destination address all in there. That's just the packet. Well, the bit level can't read that. It can't see it, can't understand it. So it has to deal with the physical addressing of it, which would be the source MAC address, which matches here, and the destination MAC address, which is here. Does that make sense? Why would you want a difference between a hub and a switch? Yes, Aaron.
A hub, I just browsed. Okay, a hub copies all the data sent to every port, and the switch only goes to the specific port if it needs to.
That's exactly right. Think of a hub as a broadcast. I turned on the speaker in this room and started talking. That's a broadcast. A switch, if I'm looking to this side of the room and I'm sitting mine over here and I want to get to Kristen, it goes directly to Kristen's port. All right? I'm going to go through all that. Blah, blah, blah. Mapping an IP to a MAC address. What is that called? ARP. Address Resolution Protocol. So if you're looking at an ARP table, this is something similar to what you'll see. Make sense? Now what it's saying is if you're outside of this range, okay, A can now send it to the router. The router says, okay, I'll forward this frame because it's based on a route in my routing table. In other words, he can see this 10.10.0.254 address is not one of these guys, so it's going to send it on out to the 10, whatever range that's on. All right? What happens if I remove that mapping of the 10.0.3? What'll happen? You can't get to it. Thus, that's how ARP poisoning works. Or you can say, this MAC address right here needs to be sent to this IP address and it'd be yours. Or some other. Okay, that's how you poison tables. You can remove things from them. You can add them. Broadcast issues. ARP just sends broadcast messages. So you want to get as much ARP information out of your network, because you're just going to flood your local network. It's like sending UDP. Any questions? That's Ethernet. Planning networks and cables. When you're first thinking about how to set up a network, what's your first thoughts? Cameron, what would you want to do when you're going to set up a network?
I want to make sure it works.
But even way before that. When you're saying, okay, this room does not have any Cat 5 in it whatsoever, there's no connectivity, you're going to put 28 computers in this room. What is the first thing you need to know?
See if they'll fit.
Well, yeah, it'd be nice to know if the 28 computers would fit in the size of the room, right? It's true. Can't tell you the number of times I've actually seen companies try to fit 4 or 5 computers in a room that you barely get one in. Okay? Does it have adequate heating and air conditioning? Does it have electricity? That might be a big one. Do I have access to a switch in this room? How many lines am I going to have to run? How big is the room? All its dimensions. How far is the LAN drop from the switch to that room? Well, I need a local switch inside that room so I can keep my not have attenuation. The security of the room. What are the security factors? There's a lot of things you need to think about when you're creating a LAN environment. What kind of computers am I going to have? What kind of network? Am I running a 10 base T, 100 base T, 1000 base T network? What am I running? Here's some things you want to think about. What is the biggest one always? How much is it going to cost me? How many ports am I going to need? How fast am I going to need it? Am I going to be scalable? Is it going to be a modular? Can we expand, make more and more? And is it going to be manageable? Is it something we can actually do? All right. Take a look at this. If I connect all 8 of these computers to that one switch, what happens? 8 computers are done. If I put 5 switches in the middle and have just one backbone for each one of them, if this switch goes down, what happens? I just lose these 2. But again, if this one goes down, what happens? I lose everything. Cody, you starting to recognize this now?
Somewhat.
Now let's say I put 6 switches in here. So I have a redundant one in the center, redundant everywhere except for right here. So if this switch goes down, I'll just lose those 2. But if it was redundant, I'd still lose it because that switch. But if I lose this one, I'm still functioning. Everyone wants to know why you put a patch panel in the wall. Here is exactly why. From the computer, you have that patch cable that goes into the wall, right? Everyone sees that port. But from there, how does it get to the switch? All right. This is what my network troubleshooting and management course in the interim did. And Cody and I worked on this again Saturday. From this jack, you run the cable directly to a patch panel, leaving enough maintenance room on both sides of it in case something goes wrong. You can still have a little slack. From the patch panel, then you run a little patch cable to your switch. And your switch is connected to your backbone, which is connected to your router that goes out of your building. Make sense? Everyone see that? How many of y'all are going to be in my network troubleshooting management design in the fall? You're going to be in that? No, nope, it'll be in the fall. 16 weeks. Well, it's a hybrid. Huh?
I don't like hybrid classes.
16 classes. Well, you're building the entire network. So, all right. Here you go. Here's how you make LAN connections. If I'm going from here, from router to router, I need a crossover. Why? They talk on the same level. So if I'm sending the transmit out, on the other end, I'm sending this. The receive is going out on that same line. So if you cross them over, then you have the transmit line and you have a receive line. Otherwise, you'd have two transmissions going this way and two receiving, not getting anything because there's nothing on that.
I thought they auto switched to do it since 2007.
No. That's only on a a managed switch.
Oh. Just wondered.
If you have a device like from here, when you have a switch to a computer or a switch to a router, there's where you have your straight throughs. You don't have to have it, a crossover. If I'm going to switch to a switch, I have to have a crossover. Think of it this way. Or if I'm going from a computer to a router, I have to have a crossover. If you're on the same level of the OSI model, you have to use a crossover. Does that make sense? Just remember it that way. My favorite and fun thing to do. T568A and T568Bs. If you're on A's, it's going to be greens and then the oranges are switched versus the B's. Okay? On T568B, that's my favorite one. That's really the most common that you're going to have. It's going to be white, orange, orange, white, green, blue, green, white, brown, brown versus white, green, green, white, orange, orange, or white, orange, blue, orange, white, brown, brown. That's the difference between A and B. Now, if I took these two like this, I've now made a crossover. Or if you really get fancy and you decided you want to have a little fun and make a straight through cable, all eight of them lined up, make sure it's the same on the other end. I mean, not a straight through, but just literally. What? It's a useless cable. All right. Again, I forgot to bring my little small one in so you can see this Mel Smart serial. That thing is extremely small. It's about as wide as your VGA cable on the back of your computer, and about half the width from top to bottom. Real small. And then you have the Winchester block type, which I absolutely hate these. I got a couple of them over in the other room. But these are your X dot or V35s and stuff like that. You don't ever want to use these. If you can get out of it, start using the smart serials. They're a lot faster. They run on SCSI backbone. All right, console cable. It's what we call a rollover cable. Why? Because you can roll over it. All it takes is an RJ45 on one end and a DB9 connector on the other. I showed y'all one earlier this semester, the blue one that I brought in. That is a console cable. We talked about the different icons earlier in the semester, right? Here's a little bit of the VLSM. We did this last week. Remember on the board I was breaking down chapter 6 and 7, right? We did Packet Tracer 6 and 7 in here. Have the instructor. I'm on 1600, needed 23. Well, what does 23 give me? That's actually wrong. It's 24 if I wanted the full octet. Oh no, 23 would give me, that's right, there's a .1 there. So 0.1 to 1.254. Start down here. I'd start at 2 because that's my next network. and I'm on 25, which means I'm going in, so I'm going by 64s. What in the world is it doing? Or I'm sorry, 25 goes in by 128s. So then I'm on 128, 2.128. Now I'm at 26. Now I'm going by 64, so I'm at 192, 192, and I notice I'm at 30, which gives me those two usable. You have 4 IP addresses, right? So I have the 193, 194, and then the rest of them are unused. So you can see how we just kept breaking down our network. That's VLSM. That's what we did. That's just a graphical way to show you what we did. You okay, Cameron? All right. I could give you how many hands-on networks, how many labs, but you need to know what the icons are. And then router interconnecting two LANs. Basically, you have these coming into a hub that comes into a router that comes into a switch that comes back down to computers. Here's a LAN, here's a LAN, even though that should have been a switch and not a hub. Router interconnecting a LAN into WAN. The router goes out to the WAN on the serial port, comes in on the fast Ethernet port into the LAN. Pretty simple, right? Connecting subnet or counting subnets. How many subnets do we have here? 3. Why? 1, 2, 3. Buckle my knee. Any questions? Have I really just gone through, I told you it was going to take about 20 minutes to get through these two, didn't I? All right. All right. What we're going to do now is we're going to cover Chapter 11. Which is configuring and testing your network. Well, now that we've created our networks, let's go ahead and start talking about the different avenues of putting your network together and what devices and what commands are embedded in an iOS. When I refer to iOS, I'm not talking about Apple products in this class. I'm referring to the Cisco input output system. All right? Or, in other words, your inner network operating system. Okay? We have what we call NVRAM, non-volatile RAM, which also would be what? ROM. Okay? We have what we call a default startup configuration. So when the router or switch, whatever the device is, boots up, it loads this from memory. That's all it does. Now it copies it into RAM so that we can function and run off of it. All right. Any commands that we type in and change our configuration, we're changing in the running configuration. Those are the two different configuration types. So if I ask you on your test, what are the two types of configuration? What do we have, Todd?
Startup and running.
Startup and running. Now, here just kind of shows you how things work. All right. We have the user exec command. Basically, you're going to have a router with a greater than symbol. That means you're in the user mode. So, I'm not going to confuse you. Let me open up a packet tracer. And let me put out a router. I didn't want two, but... Okay. Notice that I'm booting up right now, right? It's asking me down here. I know you can barely see it, and there's nothing I can really do about this. Do what? Where's the zoom bar? Oh, the magnifier? Let me see. Where's my magnifier? All it does right here is it says, do you want to configure, or do you want to continue with the initial configuration? I always say no, or you don't want to go through all that mess because that takes you about 40 minutes to do. We have router greater than symbol. That is our user mode, okay? Then we have what we call the executive mode, or privileged mode. Y'all remember that from Unix or Linux, right? Elevated command prompt. If I type in enable, I'm now here at the exec command where I have router with a pound sign. So when you see with the pound, anything, whatever you want to, you can change the name of router to be whatever you want it to. You can call it Kristen if you want to. So Kristen pound sign, that tells we're in the enabled mode. All right. That's where you can do your debug commands, show me these commands, configure terminals, things of that nature. Every part of a router or a switch is called a terminal. So anytime you make a change to something, an interface, you got to go into configure terminal mode, which we will go to here in just a minute. Once you go into a configuration terminal, you'll see the router name, and in parentheses, config. What does that tell me? That tells me now that I'm in my third level of the iOS hierarchical structure, okay? I can now change my host name. I can enable a secret password. I can change my IP routes that we've been doing. I can change my interface from Ethernet, serial, BRIs, fast Ethernets, gigabit Ethernets, whatever the module is. I can also do my routing commands, my RIP, my OSPF, my EIGRP. Maybe put an extra space in there. And we can go so forth and so on. To get to the fourth level, you'll see a config-if. That means I'm in the interface. One interface. And in that interface, I can say its IP address. If I have an IPX address, I can put that in. I can do encapsulation or put it in a tunnel with IPsec or whatever. And then I have the shutdown, no shutdown commands. There's clock rate. Things of that nature would all be in that fourth level. Does that make sense? Y'all kind of seeing where these commands are going, right? So how do we do certain things? Want to make sure that you understand that it is context sensitive. Let's say I don't know how to look at the time, or if I want to set the time. I can go CL and then hit a question mark. That's going to list every command out here that has CL to start with. Make sense? Okay. I can do clock. Now that I want to look at clock, I can do space. Then I put the question mark. Set. So I can set the date and time. Well, if I just put clock set, it gives me incomplete command. Why? Because I haven't completed it. So what that tells me is I can come down here, hit space, and hit the question mark, and it says hours, minutes, and seconds. So I say clock set 1950 0. It still says incomplete command. Why? Well, I'll come out here and I put down the question mark and it says day of the month or month of the year. So I come out, clock set 1950 0, 25, the day of the month, and 6, the month of the year. What's wrong with that? When it says month, it wants the month, like June, July. And then also you have to put the year out there. But that kind of tells you how you can work around to kind of figure out what commands will do. So if you're not sure what the command can do, hit the question mark. If you put it with words, then it tries to find out, is a wildcard, what's left on it. Does it make sense? We have 3 different areas that you need to be familiar of. You have your flash memory, which is just for the iOS itself. You'll never use it unless you're putting in a new iOS. All right, so don't worry about it. We have our NVRAM, which is the backup configuration file. That's what is stored in ROM when you are looking up your startup configuration. So the first thing we're going to do is, after we make some changes, we're going to do what we call copy, run, start. So I'm copying my running config back to my starting config, so the next time this router boots up, it goes back to whatever this startup config. So when I copy this over the startup config, I now have my current information. Does that make sense? Then in the RAM, we have our iOS that's loaded, all the programs, all the active configurations that we're doing in the tables and buffers, like the routing tables and things of that nature. So what it does is when you click Show Version, it will tell you what the iOS is, what version iOS is. Now, if you have a Cisco login, you can go out there and you can download the newest version of the iOS, which can come with more updates, more features. You can do show processes, CPU. It'll show you everything that is running on that router or that switch. You can do show memory, stacks, and buffers. That gives you everything that's in here. You can also do show IP route. Showing interfaces is all in the interface area. And then running config is also in here in your active configuration. Your startup config is here. Does that make sense? Startup says it's the backup. Well, that's the first thing that's loaded into memory. So why is that the backup? Because if everything fails, when you turn back on, you're in your backup. That's why they call it the backup. So here's basically another graphical view of how to do it. You have your user mode, your enabled mode, your configure mode, and then your special configuration modes. If you're in a terminal, you're going to have it. If you're in a line, or line terminals are going to be your telnet ports, things of that nature. And then you can do a config of a router. Okay, those are your 3 specific configuration modes that you'll see, and the prompts will show it like that. For the most part, what you're going to do in this class, you're only going to be here for configuring the interface. You will come down here as we get into EIGRP, OSPF, and RIPS, because you got to go into router and then set up your networks. Okay. You see these guys right here, how small these are? That's the smart serial that I was talking about. This module is only about that big. So this is a WIC 2T. Has 2 terminal ports, but they're serial connections. All right. Right here we have a console port. This is where you would plug in your console cable and stick your DB9 on a computer so that you can program all this. You have 2 fast Ethernet ports or Telnet ports, whichever way you want. Then you have an auxiliary port, which is for modems. So you can dial in as a management port. And right here, you see these yellow ones? These right here are all fast Ethernet ports. Yellow designates fast Ethernet. Blue designates serial. Red designates BRI. I mean, Cisco color codes them that way. All right. Without network names or devices, it's difficult to identify where traffic could be sent, right? So we go in here and we're going to put a host name for each one of the routers. Why is that important? Because if I had router, I don't know which router I'm talking about. So if you identify them as which one they're at, it makes it easier to identify. So all you would do is go in here to enable. Enable, you go into config T. I say config T, it's configure terminal. That allows you to go into that 3rd level, right? And then in that 3rd level, we have our configuration. Then we change host name to Atlanta HQ. So that router name is Atlanta HQ. All right. Line console 0. If I'm trying to limit access to things, usually it's going to be line console 04, so that your 4 VTY consoles are not lit up. Password Cisco, log in. Boom. Return access. Then it'll ask you for a password. You'll never know how long your password is. It should be a blinking cursor. If you forget it, just hit Control C, and it'll ask you again. All right. And then once you pass it, then you can get into the switch. Notice we have switch, just like we did with router, which comes into user mode. All right. Your terminals, your line terminals are VTYs, 04, password Cisco, log in. Then once we've logged in, we can do enable password San Fran, enable Cisco, or enable secret Cisco. What have I done? All I'm doing is say encrypt the password Cisco. I can go enable secret San Fran too if I wanted to. And then you can do what we call a banner or message of the day. Now this is where it gets interesting. And we're going to start working on these banner of the day messages on the router. We're in config mode, so we're in that third level, right? Because you've got user, then enabled, then config. Banner space MOTD, which is message of the day, space another pound sign. You're thinking, why do I have a pound sign here? Anything between these two will show up. Prof. Stokely is a dork. It would show up. But if you don't put anything on the end of it, it'll say, invalid command. All right? So this is going to be one set of slides that you really want to look at, especially on your midterm. Because I may say, how many terminal lines do you have? How many? We just went over it. How many terminal lines do we have? What? Nope. How many terminal lines? Todd? Nope. 5, 0, 1, 2, 3, 4. Now that we've made some of these changes, right, we can do what we call the show run config. Now you don't have to type out show running dash config configuration. All you have to do is say show run. You put sh space run and it'll do it. That's what's neat. Back in about 2005, I believe it was, is when they switched to being able to do that. Used to, you had to type out the whole command. They made it more friendly. All this is going to do is show everything, all your active, whatever's set up in your commands. Now, by the end of this semester, I'm going to teach you a trick that is going to make your life a lot simpler. But I'm not going to show you until after you learn all the commands. All right. You can copy this active configuration to the NVRAM of the startup config by saying copy, run, start. Like I've said a couple times. Now you can also copy it to what we call a TFTP, or Trivial File Transfer Protocol. If you have a TFTP program you can get down from SourceForge or wherever, you can copy it down to your TFTP server on your local machine and store it. I would highly recommend that. Because if your router dumps, you're screwed. So anytime you make the changes, you can always do it. You can say the name of the configuration. You can call it whatever you want. In this case, Tokyo.2. And the server is 131.108.2.155. Yes, that's the one I want. Then it writes it and gives you 6 exclamation points. That tells you how long. Tells you that it's doing good. If you get anything other than that, if you get a period, that means it had an error. All right. So how do we get into the iOS? Now that we've known a little bit of basic commands, we've got to get in through HyperTerminal or some other Telnet protocol. Now, the easiest way to do this process is to do HyperTerminal on a Windows XP machine or PuTTY on the newer machines. All right. Now, you can use text file to back up and restore configuration settings. And all you do is you do a copy run start, capture the text, and then stop. Save it. And later on, highlight it all, control copy, go into the enable config mode, control V, hit enter, and all the commands that you've ever put back or go right back in. But we'll get to that a little bit later on. All right. We have what we call configurations of the router interfaces. Now, this is very generic in type. Okay, we have interface. What type of interface? So that's going to either be your serial or Ethernet, fast Ethernet, gigabit Ethernet, BRI, PRIs, things of that nature. The port. Maybe there's only one port on this router. Or if it's on a switch, it'd be on that one port, port 24. But usually you're going to have a slot because what we call routers, they're module in nature. So you have multiple modules that have multiple ports on them. So that you'll call it in the slot that module is in. So it would be, if you have fast Ethernet 0-1, I am now in the 0 module slot with the first port. Does that make sense? Now if I have, routers have two different types of modules. They have that little small one that we showed with the WIC 2T in there that had those 2 serial connections. Then they have a huge 4-unit version. Now in that 4-unit, I can have 4 smaller slots in of it. So you would reference it in a tertiary level. You would say my slot, which would be slot 2 usually, which is the big module, could be 3. Subslot, what's that next slot where I'm putting in whatever card I'm putting in, whether it's Ethernet or serial, and then whatever port on that card. So if I have serial 000, I'm looking at the module that has 0, the slot that has a 0, and then the port that has 0, which is usually your first port anyway. All right? Any questions? This is one thing that was asked of me earlier. If I come in here and I just type shutdown, that administratively shuts down my port. Nothing will work on that port until I turn it back on. Okay? If I type in no shutdown, it'll be down, not administratively down. It'll be down until there's connectivity on that port. Then the port turns on. So, for example, when you get into number 11 here, you have a router and a router. The serial ports are 0 and 0, 0 and 0, right? Your slot 0, port 0s. They're connecting on a WAN interface. If they're both administratively down until I put no shut, I've configured both of them now, both of these ports with IP addresses and subnet masks, and put the clock rate on my DCE connection. Then I put in there no shutdown on both, or on one, and I'll leave the other one off. I don't put no shutdown. They're still not going to get connectivity. This one will say it's now turned down, but it's not administratively down. If I go over there and put no shutdown on the other router, router A, now they're being able to talk, so the ports will come up. Does that make sense? The only time a port is up is when it has connectivity. Then it's down or it's administratively down. Administratively down means you've turned it off. And then once you get done with that configuration, you exit. The only thing it did not talk about in here is clock rate. So here's an example of what we would do. Interface fast Ethernet 00. Well, here is my module of 0. And here's my 0 port. You can't really see it, but it says FE00 right here. Okay? I'm assigning an IP address of 192.168.10.1 with a 255.255.255.0 network. No shutdown. That's fine. That port is down until I plug in a Cat5 that has a link on the other end. Any questions? All right. Here's what's cool. On that fast Ethernet 00, we can add a description to say this description, this is building B sells LAN. So anything, when this is connected to a switch, that's the building B sells LAN. So it's easy to identify it. The serial 00, which is going to be this one right here, or maybe this one. I can't really see what the serial is on those because they're blued out too much. It's just saying to Perth. So I know that this line right here is going to my Perth router. Does that make sense? Adding descriptions helps you manage your ports better. I'm not going to talk about... Okay, well, I guess it will. If you ping the local host, it's always going to give you a connectivity because you're talking it to ping to itself, right? The 127.0.0.1. If I ping something, I'm sending out a request to a router who then returns it to me. That's all it does. So in this instance, if I'm here and I ping, I'm sending a request to this router 10.0.0.254. It's actually going up here. It sends it back because that was my default gateway. It goes up to my default gateway, who sends it back. And I love how they spelled gateway here. Getway. Yeah, it's getting in my way is what it is. Then we have, so all it does is it just says, this is how long it takes me to get to my router. All right. You can use ping to see how much connectivity you have throughout the network. Y'all know that from network infrastructure and stuff. Trace route, basically, it's going to tell me how long is it getting from here to wherever this is. You can do the same thing that you do here. You can do it at the Cisco command line. Trace route, you can do pings, same thing, okay? We have our ARP commands. Again, those are the physical addresses which we just talked about. ARP-A will show you all the ARPs for anyone that's in your ARP table. Y'all kind of got the basic command line understanding now? Did I just blow your mind? Alrighty.